Okay, now let's look at question number 5. This time around, we have a translation, but it's not a rectilinear translation. It is a curvilinear translation. How do you know that? Because if we look at point G will be traveling like this. Okay, because of the 100 Newton force, there will be point G will be moving in a circular path, but it will not rotate. All right. So let's read the question first. At the instant shown, the both rods of negligible mass swing with a counterclockwise angular velocity. This is another a clue that this is a curvilinear translation, because there is a angular velocity value given. So we want to determine the tension developed in the rods. So these two rods, this one and this one, is a negligible mass. This is this rod. This two rod is used to hang the bar, the 50 kg bar. Okay, this is no mass. No mass. Okay. So what we want to find out is that what is the tension developed in these two rods, as well as what is the angular acceleration of the rods. All right. So we start with the free body diagram. Okay, there will be a weight pointing down from center of gravity, point G, and there will be two tension developed. The tension at rod AB as well as tension at CD, and there's a 100 Newton applied force on the left hand side of the bar. So this will be the free body diagram of this question, this problem. Next we move on to the kinetic diagram. Okay, when we are dealing with with the curvilinear translation, we are not going to use x and y coordinate system, but we will be changing to t and n, which is tangential and normal coordinate system. So tangential is tangent to the circular path. So when we look at point G, tangent is like this. Okay, this is so this is tangent to the path, and from this magenta circle you will know that the center point is over here, somewhere over here. So normal, so this is tangential axis. Normal axis is from point G pointing to the center of rotation. So this is normal axis. This is tangential axis. All right. So in this case, we know that I'm going to remove this first. Okay. We know that there is only motion in tangential axis. There is motion in tangential axis, as well as there will be a motion in normal axis, because in the end the bar is moving in this direction. Okay, because G will travel along this path like that. Okay, so there will be two motion involved in two axis, and because this is a translation, there will be no rotation involved. So that completes the kinetic diagram. Okay, now if we recall from kinematics, this is from chapter 1, kinematics. Okay, we know that A the acceleration is equal to alpha cross r minus omega square r. All right. So the first term of this equation I have explained in the first chapter. This is the tangential component, and the second term is the normal component. So when we write down in scalar form, because these are in vector form, so we will have AGT is equal to alpha times r, whereas AGN is equal to omega square times r. So you will ignore all the negative sign because that only indicates the direction in vector. Okay, now we have transformed this equation into scalar. Okay, so when we write down the equation, the first equation will be total force in tangential axis. Is no longer in x-axis. Now we are talking about tangential axis, which is equal to m AGT, and from here we know that AGT is equal to alpha r, so therefore we will have total FT equals to m alpha times r. So that is our first equation, and then we will look at tangential component. In this case, tangential is pointing to the right, so we have this one, 100 Newton force, so therefore 100 Newton there. On the right hand side is m alpha r, so m is 50 times alpha times 1.5. What is 1.5? 1.5 is taken from here. That is the distance from the bar to the center of rotation at point A and point C. So that is the value of 1.5 that we are taking. Okay, 1.5 there corresponds to this one. Okay, all right. So then from here we have alpha is 1.3 rad per second. So we have solved the first one, which is the angular acceleration. Now we still want to calculate what is the tension developed. So we move on to the second equation. So now we will calculate the total force in normal axis, which is equivalent to MAGN, and we have from here AGN is equal to omega square times r. So we will have m times omega square times r. Okay, so in normal axis, which is positive up according to this definition, so we have TAB plus TCD minus the weight, so this will be the weight, all right, and on the right hand side it is M50, omega square is given 5 rad per second here. Okay, so 50 times 5 square times 1.5 is still referring to this distance from the bar to center of rotation at A and C. Okay, so from here we will have TAB plus TCD equals to 2365.5. We have to move on to the third equation to solve the problem, which is the equation of moment. So now moment is still calculated about G, so sum of mg equals to 0. All right, so we have AB is going in this direction, which is clockwise, therefore it is negative because we define counterclockwise as positive, and TCD is going counterclockwise to G, so this will be positive. The distance is 1 meter for both, so we have in the end TAB equals to TCD equals to 1183 Newton.